Okay. So we've gone pretty much everything we need to do slash well, there's more we can do with the derivatives, but in this instance, this is a good like stopping point. Covered all the bases. So you're ready for a summative. So for today's video lesson, if you look at the bottom, there are two attachments. One's the actual project description, and the other one is sort of something to help you guide your project. So I just kind of want to walk you through it because at first glance, you're like a little overwhelmed. But I just want to remind you it's doable. Basic broad strokes is make a test and it has to have eight problems. We'll get into the specifics for the problems. You have to record yourself solving a couple of them and make sure you provide an answer key for your problems. Okay? So that's the basic gist of it. So now let's get into the specifics. Use this as a callback for what you have to do in case you're confused. Okay? So you have to create a test for your chapter of application of differentiation. You cannot use any problems that we have seen or used before, including Khan Academy. If it is found that two students have used the same problem or problems eerily similar, those students will receive a score 0. So if I see that you guys have the same problem except one version is, I don't know, doubled or tripled or multiplied by a constant, but it's still the same problem, you might run into a little bit of difficulty. So just don't do it. I'll be available for office hours if you guys want to run stuff by me and just kind of work through stuff. But you have to try to come up with it, okay? And I can just kind of help guide you a little bit. So, your first problem should be a straight line motion problem. So, if you go back to a couple weeks when we were talking about, it was the end of the second week of remote learning. So, like right before we had the spring break, we were talking about the particle's direction, which is talking about the velocity of the graph, the particle's acceleration, the motion, if it's speeding up or speeding down. So that thing. So if you go back and look at the lessons that we did, Khan Academy has a couple of resources you can look at to kind of refresh yourself on how to do it. So this problem has a position function that must be a degree of at least 3. So keep that in mind, and you have to make sure that the function, right, has a particle moving left and right. It speeds up and it slows down, and you kind of give a reason as to why that's happening. It says use number 1 from the review packet from Friday's work as an example. So let's reference that. Over on this tab, we have the review packet that is mentioned, okay? It'll be titled Honors Calc Test of something, right? Review applications of differentiation. So it's something like this. A particle is moving along a horizontal line with the position function as given. Do an analysis of the particle's direction, acceleration, motion. So you can take that wording, but the function provided, you have to create your own, and you have to answer the question as well, right? So it's not just here's an equation, I'm done. No. Go ahead and answer. Show me your work. Make me an answer key for the test question that you just made. That's what I'm looking for, right? So if you scroll down, I provide you an answer key as well for work that someone did. So this is what I would call something acceptable, right? The way that they solved it, they clearly tell me what the velocity function is, what the acceleration function is. They find solutions, and I can see how it all kind of applies. And notice how they write their answers out. They talk about the velocity, the acceleration, the motion, and as well as the position, right? So if you need help with the motion, again, just Khan Academy can help you with that because we had practice specifically based off that. All right. Then the second question is function analysis, function form. So you have to create a function and determine the following: the intervals where the function is increasing, decreasing with reasons, the relative extrema, maximums given at points with reasons, the interval where the function is concave up and concave down with reasons, the inflection points given as points. So you can't just say x equals. You have to actually find the coordinate point, the x and the y, right? When I say given as points, x value, y value, with reasons. And the reasons part is just you explain how you know, like how you explain your work, your justification for it. So what you've been doing, if you've been doing the homework right the last couple weeks, you should be okay with this. Just keep doing what you were doing. All right. And if you weren't, I give you feedback like, hey, where's your work? You need to show more work. Then that's what you need to add to the assignments that you have. It says use questions 13 to 15 as an example. So if you go back to that other sheet, and you look at the example given to you, so 13 to 15, it's something like this. You could just, again, take the wording, but make your own equations, work through them, and again, provide an answer key. So let's see how this person did with theirs. Okay. Nope, that's not it. That's number 12. Okay. So something like this. Number 13. Okay, we see this, we see that. They kind of explain it. They talk about the increasing, decreasing, talk about the inflection point. This to me reads as a solid, good answer, and that's what I'm expecting for them. But you have to be careful because it's not just any types of equations, right? Well, actually, I don't specify that, so yeah, that's all you. Oh, sorry. It has to be a degree of at least 4, and it has to have all of these components, right? So it has to have a relative maximum and a relative minimum, at least one, in order for it to count for full credit. So be careful as you're solving it. Some of you guys might want to do trial and error of, trying to get this going. Straight line motion graph. Okay, so create a v of t graph and determine the following. Where the function is moving left or right with the sign charts and the explanation for it. Where the acceleration positive negative with the sign charts and reasons, on what the interval is speeding up or slowing down, sign chart with reasons. So if you go back to an assignment that we did from that first week when we did the straight line analysis, talking about the position, acceleration, and um, position, velocity, and acceleration from April 7th-ish, that week you have problems you can draw from, and I've given you examples of this, so feel free to use those as a jumping off point. Make your own graph. It's as long as you give me a graph and you ask these questions and you answer them, you should be okay, right? And that's just 3 questions so far. The next one is function analysis. Create an f of x graph. So make an f of x graph and determine the following. Where's the graph going to be increasing, decreasing? Give me a sign chart. Where the graph is going to be concave up, concave down with the sign chart. So this is kind of what we were doing yesterday, right? You didn't have to make the sign chart, but what we've been doing with the critical numbers, the first derivative test, and the point of inflection, those are the sign charts where you make a number line. You tell me where is it positive, where is it negative, and you interpret what that means. That's what I'm looking for. But you have to do it based off a graph, right? So as long as you understand when we look at the first derivative and we have positive, negatives, or zeros or undefined, you're able to verbalize what's going on. AK, if you're okay with the assignment from yesterday, you should be fine with that. Concave down, concave up, same idea. Another one, but now it's going to be like you're going to look at the derivative and do the same thing. So if you're okay with the Khan Academy assignment from yesterday, where we're connecting f, f prime, and f double prime, as long as you can do that, you should be okay with this because you kind of had to use those skills anyway. You just have to make your own graphs. And I'm not expecting picture perfect graphs, but it should, it should be kind of like what we did for Khan Academy, where you have the graph and you can tell me increasing, decreasing intervals based off interpreting positive or negative like outputs for the function itself. And if you're not sure, again, just ask because it's not that bad. Rolle's theorem was the week 3, I believe. So the problem has to work. So you have to make a problem that will satisfy Rolle's theorem. Make sure you check the initial conditions that have to be met, and it has to be a trig function, right? The level of difficulty of the trig function is up to you, but you have to make sure you can satisfy Rolle's theorem to begin with. All right. I would suggest don't make it too easy, because if you make it too easy, a lot of people are going to have the same kind of problem, and well, that's the violation of the first rule. So I don't know, put like a transformation inside a trig function, like a sine or a cosine, even, or maybe even tangent, to kind of distinguish it up, or add a sine and a cosine, or subtract a sine and a cosine, or a sine of 2x and a sine of x kind of thing. I don't know. Just remember that it's going to be something that, don't make it too easy, because a lot of people might do the same thing, and we just want to be careful. Mean value theorem, again, same idea, and it has to have a square root symbol. So you can use a radical. And again, it has to work. So make sure that the initial conditions for the mean value theorem apply, and work through it. If you need help, they say look through questions 8 through 10 for number 6, and 11 and 12 for mean value theorem stuff. So if we go back and look, all right, let's start with the Rolle's theorem stuff. Okay, so it says here's a function, find the values that satisfy it for that interval. So you have to make sure you determine an interval where this is going to apply. So they take the derivative, they have that, they solve for it, but the issue is they didn't make sure that the initial condition worked. So that's something you need to be careful about for this problem, because if you don't check the initial conditions, it's not going to end well. And for number 10, notice it's a trig function and it's kind of simple. Right? You can have flexibility. If you think you want to use like a negative sign of x, okay. I would suggest changing up the interval where you're going to find your solution. That's a way to differentiate it from what someone else is doing. All right. If we're talking about mean value theorem, we're looking at these right here. So if you look back at the work that you've submitted for mean value theorem, it's that process. Just make sure, again, I was hounding you guys, check the initial conditions and show me that it works and find those solutions. But you have to make sure that you have a radical. So something like number 12 is what I'm looking for more than number 11. But again, you can't use that problem. So try to make your own and just see what you get. All right, absolute max and min, create a function of at least degree 3 and find the absolute maximum and absolute minimum. Last Friday, I gave you a problem set just like this. So I would suggest going back and looking at that assignment and seeing how the question is worded and what the graph looks like. So just, okay, it's not that bad. So those are the 8 questions that you have to make. It seems overwhelming at first. I get it, but you can do this. I wouldn't give this to you unless I thought you were okay. Right? So that's the basic gist of what I'm looking for. Here's exactly what you need to submit. You need to make me a blank copy of this. Then you have to give me one with an answer sheet. Then I need you to make 3 videos. One video has to solve either number 1 or number 2. A second video has to work on problems either 3, 4, or 5. That's your choice which one you want to do. And the last video has to work on 6, 7, or 8. That's where you have your choice of what you want to show me work through. And you've seen my videos where I work through stuff and I explain my steps, and yeah, they're a little convoluted and I apologize, but that's what I'm looking for. You've seen YouTube tutorials of people solving problems, so think about what you need to explain if you're teaching this to someone for the first time ever. It's due next Friday night, so for you night owls, that works for you. You guys want to submit it sooner? Even better. All right, and let's talk about what the expectation is for next week. So you guys have an entire week to work on this. Every day, I'm going to ask for you to give me an update. So for that update, I'm looking for, okay, here's a picture of what I have done so far, and here's what I'm going to work on next, right? And here's how I'm going to grade it. It's on a 0 to 4 scale. 4 is mastery. Student demonstrates complete understanding of the content. The student demonstrates complete mastery of the skills included in this chapter. All necessary elements required of that student are present, accurate, and accounted for. So your problems are good. Your videos are good. Your solutions are perfect. You know what you're doing. All right. Proficient is, okay, you understand what's going on. You have pretty good skills. Almost everything that I've asked you is there, and it's accurate. So maybe you made little mistakes along the way, but overall, I can see that you're getting there. 2, developing. Student demonstrates that they are progressing towards proficiency with the content and skills from this chapter. Most of the necessary elements required are present, accurate, and accounted for. So you're making a lot of like little mistakes, and it's hindering my ability to say that you really understand this. Limited is you're really struggling through it, but you can kind of talk about major concepts, but you have trouble executing them. Like a lot more trouble with it. And a 0 is it's really hard for me to judge what you know and don't know because your work is, when you can't say something nice. Yeah. Um, if that's the case, if I give you a 0, I'm going to ask that you meet with me outside of office hours so we can talk about what your project is and how you can retry it so we don't leave it a 0. Okay? So that's what the project overview is. And sorry to scare you, not the best way to start your weekend, but I'd rather let you know so that way if you have questions, tomorrow your assignment is just going to be give me a breakdown for what you plan to do, how you plan to approach this in a way to um, keep yourself on track and not rush and stress yourself out every day. Because it's only 4 problems and you have to solve them. So realistically, that's just 2 problems a day, which is a lot less than the work I've been giving you. So don't procrastinate though, because if you run into trouble, you may or may not have time to talk to me and work this out. So I'd highly recommend get it done early, get it out of the way.